Yes, welcome to another very important session. So here we will put all bits and pieces together, and we will see the big picture of what Python is. So far we have been climbed up almost all steps up to the on programming Python programming ladder. So we have covered object, and then expressions which generates object, and then statements which are made up of object plus keywords, and then module which consists of number of statements, and then modules together made up of a program. So now we have reached almost we have climbed up top of the programming Python programming ladder. So now we will put all bits and pieces together, and we will see the clear picture of what Python is. It's a bird's eye view. So in a nutshell, Python is this. So whatever you're seeing on your screen, that's what the Python is. So of course there are so many interconnections are there are so many dependencies on other aspects, but in a nutshell, this is what Python is. So object object is an instance of class. So in this case, list, tuple, int, float, dict, or some of the core classes, out of which from which we make some objects instances. That's why generally interchangeably we call it as list, tuple, int, float, dict as objects, but these are class come objects. When you use this int and when you execute, then what we get is an object. So here when we call that list, what we get is an object. So these are all objects. And so the second one is module. Every file of Python source code whose name ends in mod.py with an extension. The mod can be anything, the name can be anything. If it ends with an extension .py, which is called as a module. Okay, you can see here. So example, so this is one example. So type is a module, the file name is mod.py, and it has one attribute and then one method inside that, one function in it. So that function returns when you call that module with this method name. The function returns name of this module is capital MOD. Then package. Package is a collection of modules. See, this is our package, which contains a special file that is trailing underscore init leading underscores .py. So now the whatever, for example, I have given, that is the package name. Inside a root, inside a directory, you will have a package name. Inside that package name folder, you will have the first module is double underscore trailing init, and then double underscore .py. So this, and then you will have different modules in it. So then only it can be called as a uh, package. So if you go in depth, so let's discuss a little about this init, little about init.py. So here the init.py files can contain Python code just like any other normal module files that package holds. They are partly present as a declaration to Python, however, and can be completely empty. It can be completely empty or partly written. So as technically as so now we will look into another aspect of the same file. So Python might pick a dictionary that has nothing to do with our code just because it appears in an earlier directory on the search path. So now if you look into this init file more generally, the init.py file serves as a hook for package initialization. That's why it's called init file. Initialization time actions generates a module namespace for a directory and implements the behavior of from asterisk and import these statements. Because of this init file only, it is able to implement those behaviors, so that we can actually import this whatever items are there inside this package. So this init file is very much important. So after that, what we have is a library. So library is a collection of various packages. So again, a library, you will have a directory. In that you will have a library name. In that library name repository, you will have a subfolders. Those are package 1, package 2, package 3 folders. Okay. Now there is one more very important topic which is widely used while we are programming. So that is framework. A framework is a large code base or collection of data meant to provide universal reusable behavior for a targeted project. Frameworks are different from other external code bases such as libraries because they feature inversion of control 1. So some of the examples for frameworks are, if you see web frameworks, Django, Flask, and JustPy. So these are some of the examples for this. Libraries, Pandas, NumPy, Keras, PyTorch. And package, examples for the package. So packages also same, we will have inside that NumPy. And when you open NumPy, when you open Pandas, further it will have some packages inside it. And similarly modules, we will have plenty of modules such as math and OS and some other modules. Will have plenty of modules. We have discussed so far all those things. And objects we have discussed, we have gave some examples. So if you take the analogy of for this using a general library, an object for you is an alphabet and then a module. A module is nothing but a using these objects you have written statements, you have written some sentences. Using these alphabets you have written some sentences and then a paragraph, and you have put that paragraph into a page, a single page. That single page is your module. It is analogous to your module. And when you put all pages together and package it into one book, then it is equivalent to your package. A book is equivalent to your package. And a library is nothing but a general library which consists of plenty of books inside it. So this is how we can take analogy from a general or a spoken language. So your object is equivalent to alphabet, your module is similar to your page, and then your package is similar to a book because a package will have a specific folder and then a book will have a specific name. And a library is similar to a books library which consists of plenty of books in it. Similarly, a library consists of plenty of packages inside it. So this is how we can take the analogy from a spoken language uses. And then let's actually open a VS Code, and then we'll see actually I have created a library. Inside that I have some packages. So if you see, the library name is part 3 advanced module. In that module I have package 1. So package 1 consists of trailing double underscore init leading double underscore .py file, and then it has a one module. Just a minute, I have to rename it. I did not add an extension, sorry for that. Yes, so mod1.py. So this is one package, and you also have another package inside it. So basically I did not include anything. Okay, I will enter inside the package, and then I'll create dot init, and then package 2. So nothing is there. Let me create dot init so that you will also get used to it, and dot py. You can just keep it empty. You don't need to worry about that. Then mod2 dot py. Just add some attribute, name of this. This is module 2, and then info about this. This is print, and this is module which is part of package 2. That's it. We have created another. So let me go back to the root folder. So now this is our and let's consider this as a main file, and then you have two packages inside that. This is your library, and then you can call these packages also using a specific way. I will we will discuss about this in our next session. And but as of now I want to tell you, I want you to let know one thing, that is package initialization, how this package initialization works, because we have created this init file. So basically the first time when Python imports through a directory, it automatically runs all the code in the directories trailing double underscore init leading double underscore .py file, because of that these files are naturally these files are a natural place to put code to initialize the state required by files in a package. For instance, a package might use its initialization file to create required data files, open connections to databases, and so on. Typically, a trailing double underscore init leading double underscore .py files are not important, not meant to be useful if executed directly. They are run automatically when a package is first accessed. So basically that's what I want you to know. So how to write a library, and then how to make packages inside it, and then how can we overally we can package together so that we can use it for the bigger application to create a program or an application. I have already discussed how we can use these all theoretical stuff to make an application. So I have used one example, that's a web application, Django blog. You can just revisit the video if you have watched. If you haven't watched, you just go back and watch it, and then come back here so that your learning flow will be succinct. And with this, I'm closing this session, and then thanks for watching, and keep watching, and I will see you in next video.